Well, hello, welcome back to the channel. Chris Moore. Wait, this is not my YouTube channel. What am I doing? For y'all, a whole day has passed. For me, a whopping like 30 seconds has passed. So let's go ahead and do tomorrow's work. I'm assuming that you've already done your homework. You've already checked your homework. I'm assuming that everything makes perfect sense. You know how to substitute in, and you know how to check and see if I give you a solution to check to see if it's right or not. Today, we're going to go a little further. We're going to start solving these and finding what the answers are. But let's start with just a little more review on the next page of your workbook, which is page, do I have it? Yeah, page 32 of your textbook. Sometimes I say the wrong word, right? All right, so let's just start by reading here. I've got to read this word for word, but you've learned here that the big idea is that when you have an equation, say 3 plus 4 equals 14 divided by 2, the way you know this is true is that the two sides balance. They equal each other, okay? So what is 3 plus 4? 7. What's 14 divided by 2? 7. Does 7 equal 7? Yes, and so that's going to be true. 4 times 6 minus 3. What's 4 times 6? 24. 24 minus 3 is 21. And what is 3 times 7? 21. 21 equals 21. So that's how, with the basic essence of an equation is that you solve one side and then you solve the other side and you check and see if those two sides are the same. If they are, the equation is true. If they're not, the equation is false. That's really all that this whole section is getting at. You can feel free to read this in detail. They're going to start giving you some ideas on how to start solving them, but I'm just going to kind of explain it myself. I'm going to skip the class activity. Feel free to read that. We're going to jump right into actually solving these because I think it's pretty intuitive. Let's look at example 4. And they only give us, there's not A, B, or C. It's just the actual example. So they're going to give you two methods. The bar model, you know me, I don't really do those. Let's just solve this algebraically. That's where we're going anyway. So we have this x plus 17 equals 36. Now, yesterday, I gave you a number and I said, check, substitute that in and see if that works. Now, in theory, you could just start substituting in, well, maybe x is 1. Will that work? Maybe x is 2. Will that work? And just keep subbing until you get an answer. That's really not the best way to do this. That'll take forever. Remember that the goal here is to make these two sides equal each other. So now we get to this famous idea that so long as these sides equal each other, that's all that matters. What I do to one side, I have to do to the other. Just learn that now. You should just drill that into your memory. What I do to one side, I have to do to the other. What I do to one side, and that's one side of an equation, I have to do to the other. What I do to one side of the equation, I have to do to the other. With that principle in mind, I can solve this very easily. What I want to do is I want to get this x all by itself. How do I get this x all by itself? Well, right now, is the x by itself? No, there's this plus 17 in the way, right? So the general principle you want to apply here is you want to do the opposite of whatever this is to get rid of it. So this is plus 17. What's the opposite of plus 17? How do you make plus 17 0? You just make it minus 17. If I have the opposite of adding 17 is taking away 17, right? So I'm just going to subtract 17 from this side, okay? And if I do that, well, I leave the x. What is 17 minus 17? 0, that's gone. But wait a minute, I also said what I do to one side, I have to do to the other. I've got to keep it even. At this point, remember I had x plus 17 and I had 36, but I took 17 away. So to keep them equal, think about a seesaw. If I took 17 away, I got to take 17 away from this other side also. So I'm going to take 17 away from here. So let's just subtract. And 16 minus 7 is going to be 9. 2 minus 1 is 2. So the answer is x equals 19. And now you can check Is it true that 19 plus 17 is 36? And yes, that is a solution. So that's how you're always going to solve all of these. We're just going to see in all these examples, we are just going to take what's on one side. It's called isolating the x. We're going to do the opposite. And then we're just going to do one side, we do the other. Let's try one of the try it fours. Let's do try it. Let's do try it for A. Let's just do try it for A. P plus 7 equals 23. I want to get this P by itself. So I've got to get rid of that 7. So let's just do the opposite. Subtract 7 and subtract 7. That means P should equal, what's 23 minus 7? Well, 13 minus 7, 8, 9, 10, 11, 12, 13. I should know the top of my head, 6 and 1. And the answer is going to be 16. So you see how easy that is? P is 16. All right, there you go. All right, let's move on. You're going to keep working on those. I'm not going to do any more of those because that's your homework. Let's move on to example 5. Example 5. We can do that over here. Same procedure. And here we have x minus 8 equals 14. Now, the goals are the same. I want to get the x by itself. Is the x by itself right now? No, there's this minus 8. So what's the opposite of minus 8? If minus 8 is taking away 8, what's the opposite of taking away 8? Adding 8, right? So we do the opposite. We're going to add 8, which is going to cancel those out, makes those zeros just like these canceled out, just like those canceled out. But then what did it do to one side? I have to do to the other. So I'm also going to add 8 right there. And if I add 14 and 8, I'm going to have x equals 22. And that will be the answer. And sure enough, you take 22, plug it back in. Let's substitute. 22 minus 8. What's 22 minus 8? It is, in fact, 14. So that checks out as a proper solution. Almost done here. Let's go down to example 6. Example 6. Solve the equation 48 equals x plus 19. Well, I guess I got to figure out a new method, right? Because now the x is on this side over here. What do I do with that? Now, the method's y'all exactly the same. You know it's going to be the same. I have an x. I have a plus 19. I want to get the x by itself. So what do? I got to get rid of that plus 19. How do I get rid of plus 19? What's the opposite? I'm going to subtract 19. That shouldn't surprise you at this point. And then that's going to cancel out. So what I do to one side, I have to do to the other, right? So minus 19. All right, so I'm going to bring down my x, and then just that becomes a 3. That becomes an 18. And that becomes a 9. 3 minus 1 is 2. And x should equal 29. I could rewrite that if you wanted as if you prefer, x equals 29 if you really want the x on the left-hand side. You want to check, is it true that x plus 19, if 29 plus 19 equals 48, do the math, you're going to find it does. So that solution does in fact work. And you should always check. Last page, I believe, yes it is going to be example 7. This is the last one we're going to do. It's my paper. Example 7 is going to be 4x equals 52. Now this one's interesting because this one, there's no addition. There's no subtraction. How do I get rid of the x? Well, what does 4x mean? Before I just yell it out, can you figure it out? What does 4x mean? It means 4 times x, right? 4 times some number is 52. So we're going to solve this the same way. We got the x by itself. So if this is 4 times x, what is the opposite of multiplication? Division. So what is the opposite of multiplying by 4? Dividing by 4, right? So I'm going to divide the whole thing by 4. And when I do, that's going to cancel out. And now what I do to one side, I have to do to the other, right? 4. So x equals, well, what is 4 into 52? Well, if you don't know that off the top of your head, and hopefully your mental math you can, but let's just do 4. We'll go into 5 one time. 1 times 4 is 4. Subtract 5 minus 4 is 1. Drop the 2. 4 will go into 12 3 times. 3 times 4 is 12, and they work out. So the answer is going to be 13. And again, notice I took the time to write it out so I didn't make any careless mistakes, and then we're done. So x is 13. So again, the bottom line when you're solving an equation, one side has to be the same as the other. So all you're going to do is called isolating your x. So find out whatever's blocking your x from whatever's keeping your x from being by itself. What's keeping it by itself? The plus 17. Do the opposite, minus 17. What was keeping the x from being by itself? Minus 8. Do the opposite, plus 8. X plus 19. What's keeping it from being by itself? Plus 9. Do the opposite, minus 19. 4x, that's 4 times x. What's keeping it from being by itself? The times 4, so do the opposite, divide by 4. Do that to both sides, get the x by itself, solve, and you will have your answer. Check and make sure it's right. So with that said, your homework, I want you to do all these try it problems right here of these ones for the day. Try it 4, where we started. Try it 4. I did A for you already. A through D, 5, A through D, 6, A through D, and 7, A through D. All right, and with that, I will see y'all on Monday. God bless you.